Hi guys, welcome back. So we have completed the chapter 1, getting comfortable with Kali Linux for pen testings. If you guys missed these videos, the chapter 1, please go and watch. There is a 4 videos for the chapter 1. So, now we are going to see chapter 2, practicing hackers tools. So the modern security professionals has access to a wide variety of advanced tools unimaginable a few short years ago. However, we often find ourselves in situations where the only tools available are the tools already installed on the target machines. Other times, we might only be able to transfer small files to expand our foothold on the target network. For this reason, it is vital to have a good understanding of some practical tools often used, including Netcat, SOCAT, Powershell, Wireshark, and TCP dumps. So Netcat is one of the original network penetration testing tools and is so versatile that it lives up designations as a hacker's Swiss Army knife. Netcat reads and writes data across network connections using TCP or UDP protocol. Okay, so connecting to a TCP UDP port. So here Netcat run in either client or server mode. So we can use client mode to connect to any TCP or UDP port. Let's use Netcat to check if TCP port 22 is open on remote machines. Here we are supplying several arguments. So we can use client mode to connect to any TCP or UDP port. So let's use Netcat to check if TCP port SSH22 is open on a remote machines. Here we are supplying the several argument. The -n option is used to skip DNS name resolutions. So -v specifies verbose output. So we then specifically the destination's IP address and port number. So after pressing enter, the Netcat tells us several things. First, the TCP connection to port 22 succeeded. So Netcat reports the remote port as open, and next the server responded to our connection by talking back to us. It printed out the server welcome message and prompted us to log in when it is standard behavior for SSH services. Okay, so let's try to interact with the server by attempting to authenticate as its username. So our login attempt failed, but we have successfully managed to converse with the SSH services using Netcat listening on TCP UDP port. Listening on a TCP or UDP port using a Netcat is useful for receiving a network connections. Let's try implementing a simple chat service involving two machines using Netcat both as a client and as a server. So we will now use this command to connect to our Windows client with our desktop, which is a basic Linux remote desktop client. Okay, so now let's launch. So this is a Windows machines. Okay, so just maximize. So now let's open the command prompt. Run as administrator. So we will now change the directory, so where the Netcat is installed already on the Windows machines. I'm going to the nmap is already installed, so I'm going to grab the Netcat tool. Okay, files and then nmap. So now you can use the Netcat. Okay, so -vlp -444. Here the Netcat to listen for incoming connections on TCP port 4444. So we are using the -N and -V options again, along with the -L to create a listener, and -P to specify the listening port number. Now that we have bound port 4444 on the Windows machine to Netcat. Okay, so let's connect to the port from our Linux machines. So just enter here. Okay, now let's connect, just minimize this, and then here I'm going to open the new terminal. Okay, so we can use this command on the Linux machines. So let's enter a line of a text. Hello there, I am Bob. Okay, so let's go back to the remote desktop. So here you guys can see, you can type here. Okay, so our test has sent successfully, and we continue the chat from other machine, the Windows machine. So the both sides, the message has received successfully, So although this is a simple example, it demonstrates several important features in Netcat. Netcat can be used for more than just a simple chat application. Transferring file with Netcat. Netcat can also be used to transfer file, both text and binary, from one computer to another to send a file from our Kali machine to the Windows system. So we will use another client server setup similar to the previous chat example. So this is a Windows machine. I'm just adding this forward greater than symbol, and then test.exe. Okay, this is the file I have saved on my computer on the Windows machine. So this is a small minor change here. So we will now run a Netcat listener on a port 444. Okay, I mean the 4444, and redirect any output into a file called text.exe. So on our, here I'm going to press enter. So listening port. So on the Kali Linux machines, so I'm going to see that duplicate. Okay, so here, so on our Kali systems, we will push the wget.exe file to the Windows machine through TCP port 4444. Okay, so notice that we have received the feedback from Netcat about our file upload progress. So sometime it won't appear, it takes time. So this is completely normal. It means we need to make a best guess and give the file enough time to be transferred. So in this case, since the file we are uploading is small, so we can just go and check here on the Windows machine. So now we can check. Okay, so we can see now that this is in fact the wget.exe executable, which means the file transfer was successful. Okay, remote administrations with Netcat. One of the most useful feature of Netcat is command redirection. So here the -E option can redirect the input, output, an error message of an executable to a TCP or UDP port. So this powerful feature opens up all sort of interesting possibility from a security perspective. For example, consider the Commandexe executable by redirecting standard output, standard input and standard output and standard error to the network. We can bind Commandexe to a local port. Anyone connecting to this port will be presented with a command prompt on the target machine. To clarify this, let's run through a few scenarios involving. So in our first scenario, Tom is running Windows machines and Peter is running Linux machines. So Tom needs assistance and has asked Peter to connect his computer and issue some commands remotely. Bob has a public IP address and is directly connected to the internet, and Peter Tom has a public IP address and is directly connected to the internet. Peter however is behind and added connections and has an internal IP address and Tom needs to bind Commandexe to a TCP port on his public IP address and ask Peter to connect to his particular IP address and port. So Tom will check his local IP address. Okay. Now then run the Netcat. So -E options to execute Commandexe. Now let's run the command with the -E option to execute Commandexe once a connection is made to the listening port. Okay, now Netcat will bind TCP port 444 to Commandexe, will redirect any input, output or error message from Commandexe to network. So in other words, anyone connecting to TCP port 4444 on Tom machines, hopefully Peter will be presented with a Tom command prompt. Okay, as we can see, this works as expected. In our second scenario, Peter needs help from Tom. However, Peter has no control over the router in his office and cannot forward traffic from the router to his internal machine in the internal machines. So in this case, we can leverage another useful feature of Netcat, the ability to send a command shell to a host listening on a specific port. So this means we can send control of Peter's command prompt to Tom. So this is known as a reverse shell. To get this working, Tom will first set up a Netcat to listen on port 4444 for an incoming shell. So this means we can send off Peter command prompt to Tom. So this is known as reverse shell. To get this work, Tom will first set up a Netcat to listen on port 444 for incoming shell. Okay. enter. So now Peter can send a reverse shell from his Linux machine to Tom. Once again, we use the E options to make an applications available remotely. So which in this case happens to be bin/bash, the Linux shell. So once the connection is established, Peter's Netcat will have redirect bin/bash input, output, and error data streams to Tom machines on port 444. Now it's successfully connected. So you can see here. Okay. So here where the Tom can interact with the shell, sometimes it takes time. Consider the difference between the bind and reverse shells, how this difference may apply to various firewall configuration from an organizational security standard point. So it is important to realize that outgoing traffic can be just as harmful as incoming traffic. Okay. SOCAT. SOCAT is a command line utility that establishes two bidirectional byte streams and transfer data between them. It is similar to Netcat, but it has additional useful feature. So let's see how it compares first. Here the TCP4 indicates the protocol. The hyphen characters is used to transfer data between standard input and output, and the remote host allowing our keyboard interactions with the shell, and 22 is a port number. As with our Netcat connections we made earlier, we can now interact with the remote service. Okay. So next, let's look at how to start listener with SOCAT. Because root privilege are required to bind a listener on privileged ports, we need to use the sudo when starting a listener on port 443. This time we selected a TCP4 listener and used the standard out argument. Okay. So let's connect our listener from our Windows client and replicate our simple chat from earlier. So let's connect the Windows machine. With our connections made, we should be able to chat between our two clients. Let's check this. Okay, so let's try again. Sorry, the password was wrong, so that's why. So now let's check this connection now. Hello there. So you guys can see here. Great. Our bidirectional chat is working perfectly. Okay, so next we will try out file transfer. SOCAT file transfer. Continuing with the previous fictional characters of Peter and Tom. Assuming Peter needs to send Tom a file called secret_passcode.txt. So let's see in the action. So on Peter's side, we will share the file on port 443. Again, on Peter side, we will share the file on port 443. Again, we use the TCP4 listen options as well as fork which creates a child process once connection is made to the listener. Then we use the file option, the name of the file to be transferred. On Tom's side, we will connect to the Peter. We will connect to the Peter computers and retrieve the file. Once again, we are using the TCP4 protocol options and have specified Peter's IP address and listening port number. So we are also included the file options which specify the local file name on Tom's computer, on this computer, where the file will be saved. Okay, let's check this. So now we can check this. Great, our file was transferred correctly. Okay. SOCAT reverse shell. Let's take a look at the reverse shell using SOCAT. First, Tom will start a listener on port 443. So this is a standard listener with the addition of -D and -D, which increase the verbosities of the output. Okay. So next, Peter will use a SOCAT execute options, which is similar to the Netcat E equivalent. In this case, Peter will use the exe bin bash option to send a reverse shell to Tom listening socket. So let's enter and then check the port here. Okay, allow socket. So it's connected successfully. So now Tom can enter the commands from his socket sessions, which will execute on Peter's machines. So let's try to enter this any text here, text line. Hello there. So now you guys can see here the socket. As we've seen this before on the Netcat, the same process we are doing using a socket. Okay. So here you go. This is a great start, and we have covered some important topics, but so far all of our SOCAT networks activity has been in the clear. However, the communication of both a reverse shell and bind shell are not encrypted. So we can use Wireshark to capture the traffic between the attacker and the victim. So let's see this. How can we use this Wireshark and capture this traffic? So I'm going to use the same command on both the machines, Linux, what we used before on the Peter machines, and then Tom machines. We use the same command, right? So just enter, press. So now we can open the Wireshark, start. So now let's enter the text line. So I'm going, this is a This is just example. So now we can see here, you guys can see here, right? So the message has received successfully. So now let's see this Wireshark, the capture traffic. So I'm going to stop this and then type the TCP. So the connection between the attacker and then Windows machine. Select this stream, follow, and TCP stream. Okay, there you go. So now you guys can see here. So the traffic is transferred, so it's not encrypted. So now we are going to see the encrypted bind shell and reverse shell. So how can we do that? So let's go for it. First, let's see encrypted bind shell. Let's assume now that we wish to encrypt our communication with the victim, either due to we don't want to anyone in the network to sniff the traffic, or because there is an IDS in place, and this way we could fool it. So we will use the open SSL encryption for this, which is very easy to accomplish. We start by generating a key and creating your certifications using the command, following command. So I'm going to use this command now. So this is our old command. Yeah. So let's open the root. Okay. So 048 -node keynote underscore key .crt. Okay. So this is the command we are going to use for encrypted bind shell. First, okay, the reg command along with the X509 options create self-signed certificate. This new key will generate a new private key. So the RSA 2048 will specify RSA encryptions with a 2048-bit key length. Dash node will store the private key. Unencrypted key out will save the key to your file. So dash nodes will store the private key unencrypted. So key out will save the key to a file. Days specifies the validity period in days. So here I mentioned 362 days. Okay. And dash out will save the certificate to your file. So let's walk through the process on these Peters machines. Okay. So just going to enter. Sorry, Asia. So now the key, now that the key and certificate have been generated, we now need to convert them into a format SOCAT will accept. So we will now combine both the bind shell key and bind shell cert files into a single .perm file. Okay, so let's see now. So using the concatenation, so cat command, and then we can, before that, let's see this, the file has there already. Yeah, So now we can use the bind and then key and then bind set so shell PM. Okay. So now let's create the encrypted SOCAT listener. So this command 443 set bind verify 0 fork pin and bash. So let's enter now and then press enter here. The open SSL-listen option creates a listener on port 443. The cert option specify our certificate file, okay, and this verify disables SSL verifications, and fork spawns a child process once a connection is made to the listener. Now we can use the Ubuntu machines for change. Last time we used the Windows, so now we can use the Ubuntu machines. Let's say it's a John machine as a Ubuntu. Okay, let me check this version. Okay, so we are going to check this. So we will now use this command to check to connect this machine. SOCAT and then so let's give you a name. So Peter's attackers and John victims, so Ubuntu machines, so you guys can understand easily. So we will use the hyphen to transfer data between standard IO and the remote host, and then open SSL to establish a remote SSL connection to Peter's listener. So okay, verify equals 0 to disable SSL certificate verification. So let's enter and check. One moment. So we have to kill this process and restart again. For that, so we can now kill this. -92082. So because this process is already running, so we have now killed successfully. So let's try the same command. Okay, sorry. So I'm going to try the same command now. Right, you guys see here. So now, okay, now let's open the Wireshark on Ubuntu machine. Okay, so I have now opened this Wireshark on Ubuntu machine. I mean the John machine. So So the capture started already. So let's see now. Let's stop this connection now here. Okay, so I'm going to check this traffic, the capture traffic. So connection between these open door machines. What is the IP address? So you guys can see here. Okay, so now we can see this IP address 192, the Kali machine IP address, and the Linux machine, open door machine. So this is an attacker, this is a victim. So just going to open the follow TCP stream. Okay, so you guys can see here. So there is no text file because it's encrypted. Okay, now you guys can see here there is no message. Even the command we successfully passed between the two machines. The communication is encrypted, so we cannot see this because the TLS protocol. So it takes some time to explore SOCAT on your own. This is one of the many tools that will be extremely beneficial during a penetration testing. PowerShell. Windows PowerShell is a task-based command line shell and scripting language. It is designed specifically for the administrator of multiple operating systems and the process related to the applications that run on the system. Needless to say, PowerShell is a powerful tool for penetration testings and can be installed on various versions of Windows. PowerShell maintains an execution policy that determines which type of PowerShell scripts, if any, can be run on the system. For the purpose of the chapters, we will need to set an unrestricted execution policy on Tom's machine, the Windows machines. Okay. To do this, we will need to launch the PowerShell as administrator by right-clicking. Let's try this. Or else you can just go here. Right-click on the Tom button on the Windows PowerShell administrator. So proceed yes. Okay. So now we can set sorry for that. Execution policy extracted. So when it's prompted, so we need to click S or Y button, sorry, yes. Okay, so to verify the execution policy has been updated, we can run get execution policy. For that, execution policy, then enter. So here you guys can see here, so PowerShell is both responsive and powerful, enabling us to perform multiple tasks without installing additional tools on the target. So let's explore PowerShell a bit more to demonstrate how it might come into play during a penetration testing. PowerShell file transfers. Continuing with the Peter and Tom, we will transfer the Tom will transfer the Windows version of wget from Peter to Tom using a PowerShell. So we will transfer the file over HTTP, so we will quickly copy wget.exe to our web root and start our Apache web server. Okay, status, let me check the status first. Yes, it's active. Let me restart. Okay, now let's go to the Windows machine. So because of the PowerShell and flexibility of PowerShell, transferring a file is not as straightforward as it would be with the Netcat or even with the SOCAT. So making these first few commands a bit confusing at first glance. So let's go to the Windows machines. We will execute the command, then break down the components. Okay. Okay, so now we can see that the command executed, the file was transferred and it executed without incident. Okay, let's break down the PowerShell command that made this happen. First, we use the -c options. This will execute the supplied command wrapped in double quotes if it were. So first we use the -c options. This will execute the supplied command wrapped in double quotes as if it were typed at the PowerShell prompted. So the command we executed contains several components. So the new object command lets us instantiate either a .NET framework or COM object. In this case, we are creating an instance of web client class which is defined and implemented in the system.NET namespace space. The web client class contains a public method called download file. This method requires our two keys parameter, a source locations in the form of a URL and a target locations where the retrieved data will be stored with the wget.exe. With the wget.exe executable downloaded on Tom's computer, this Windows machines, he can use it as another tool to download additional file or continue using PowerShell for this purpose. PowerShell reverse shells. In these sections, we will leverage PowerShell's one-liner to execute shells. Begin with the reverse shells. First, we will set up a simple Netcat listeners on Peter's computers and the Linux machines. Next, we will send a reverse shells from Tom's computers again. So next we will send the reverse shells from Tom's computer. Again, this is not as syntactically clean as Netcat or SOCAT, but since PowerShell is native or most modern Windows machine, it is important that we explore this PowerShell equivalent. To begin, let's take a look at the code and then break it down. So this may seem extremely complex when compared to previous tools we have used. However, PowerShell is not a single function tool. Because of this, we must use a complex syntax to invoke complex functionality. So this code consists of several commands separated by semicolon. First, the client variable is assigned. the target IP address and port number. Okay. Then the stream variable gets a network stream class to facilitate sending and retrieving data. The stream variables gets a network stream class to facilitate sending and retrieving data. And then byte array called byte is used as our buffer. We then enter a while loop that contains the various lines required for reading and writing data to the network stream. Note that the IEX invoke expression commandlet is a key part of the code chunk as it runs any string it receives as a command. And the result of the command are then written through the data stream. Lastly, you can see here a call is made to close the client connection. So this code can be ruled into a admittedly lengthy one-liner to be executed at the command prompt. So now we can check this IP address. So you guys can see here. Now you guys can see here the IP address. When we check our listener, we see that Netcat received the reverse shell. This powerful sequence works as expected. So remember, by simply replacing the IP address and port number, we can easily reuse this reverse shell command. Okay, that's it guys for this video. So for next videos we will talk about the more tools like PowerCat. Okay, so please subscribe my channel, press the bell button to get more update, share the video to your friends. Have a good day guys. Bye bye.